Hello and welcome to today's mini lesson from the GCSE PE portal. Today we're going to be looking at skeleton structure, or more specifically bones and the shapes that they come in, which there are four. And what I've got on the whiteboard behind me is a table which, if you use and you can remember when it comes to revision and when it comes to your exams, it's going to help you a lot to remember the key things that you need to remember for those exam answers. So to kick it off, we're going to start off with the four types of bones. Then we're going to move into the functions of each bone, and then we're going to go into a sporting example where these bones are prevalent or they come most in handy. So to start with, we have the long bone. Now the long bone acts as the bone which produces movement. Muscles attach to long bone, well, muscles attach to lots of different types of bones, but if a muscle attaches to a long bone and then contracts and pulls that long bone, then a gross or a large movement is going to be produced, because we've got this lever, this large lever, which can be moved through an arc, for example, the humerus, during a tennis serve. Because our pectorals are pulling on that humerus bone, it gets taken or swept through this large arc, and at the end of that bone, at the end of the long bone, high speeds are going to be attained. So we've got the long bone with the function of movement. I'm going to put move there. And a nice sporting example could be tennis, but again, it could be any sport that generates, or not generates movement, but we need to generate lots of movement and large movements to move quickly in order to be successful. So a golf swing, for example, if we look at the humerus again, it could be a rugby kick conversion when we're talking about the femur. Okay, so the bone that connects from your pelvis down to your knee joint, your femur needs to move in a gross action to generate enough power to transfer it into the ball to then kick it through the post and to potentially score a conversion. So long bones, muscles attach to them, muscles contract and pull that long bone to cause large movements. Sporting example where it's handy or we need them could be tennis. Second, we have short bones. Let's put short there. So short bones, these are the ones which are wider than they are long. Okay, they're quite prevalent in our hands, so hands and our feet, and their main function, their main role in the body in sport is for stability. Because they're wider, they're quite short and squat. So it actually acts as a good almost anchor or pivot for the longer bones to move around. So if we think about our hand or our carpals, then the main function is to be stable and to cause smaller movements. For example, we just spoke about tennis, where the long bone is causing that larger movement, but the short bones, they're the ones that actually wrap around and hold on to the handle. So they're responsible for these slightly smaller movements, slightly more precise movements, but we need them and they're essential, you know, for the sporting action in general. So they stabilise a joint, they can act as the pivot point for longer bones to move on, and they can help produce small precise movements such as around a handle, or if we're perhaps a gymnast on a beam, the person or the performer is relying on their short bones in their ankle to keep them upright, and as different weights and high forces transfer through their body, these short bones serve the purpose of stabilising that joint so they don't topple off, falling off, and then lose their points in that performance. So, short bones, they help stabilise, they help produce precise movements, and an example there could be gymnastics. I just put gym, balance. Ooh. Just about fitting on there. So, long, short. Next one, we have flat. Flat bones. Now, a good example of this would be the sternum in your chest, because your sternum or any flat bone is there to dissipate force. So, let's just take your hand, for example, as the rough shape of a flat bone. So it's got that large surface area, quite thin. If there's a force that makes contact with that bone, it almost ripples out through the bone rather than going directly through and causing damage to the tissue that resides behind that bone. So in the case of our sternum, we've got a heart behind there, we've got our lungs behind there, two very soft tissue organs which we really don't want to be damaging. So there's a flat bone, there's almost like that armour plate in front of it, so that when there is a force coming in, the bone wears that impact, it dissipates that force out, and the organs behind are protected. So a sporting example of that, so the sternum function, protect, could be rugby. So a rugby tackle. I'll just put a rugby there. So a rugby tackle where there's a high impact or high force coming into the performer, and possibly the shoulder or an arm or any parts of the body, especially when you're talking about a ruck or a scrum or something like that, and there's a bit of a breakdown. That sternum on a performer is there to protect the organs behind when that force makes contact. It dissipates that force, dissipates the energy, and it protects those organs behind. It could be in football, where a performer is chesting the ball down, and that ball is coming at some speed. Without that sternum there, without that flat bone protecting it, injuries are going to be caused. Another example could be boxing. Our cranium, or our skull, is made up of sort of fused flat bones. It almost looks like a jigsaw piece, really. But they're flat as well. They're thin, they've got a large surface area, and if a force hits that, this main job is to protect what's behind it, which is the brain. So flat bones, they're there for protection. You could use rugby as an example in the tackles, football with an object hitting the person, or perhaps in boxing, when you've actually got the intention of trying to injure someone by throwing punches towards their head. The last bone we have is irregular bone. So if I just put here irregular bones. Now these haven't got a uniform shape. There's lots dotted around the body. Now the purpose of irregular bones is, well, they specialise. There's a certain function that they perform. So if I just put here special, they serve a purpose other than to cause gross movements, to stabilise joints and to cause fine movements, and to protect. Now, it might encompass some of those in what it does, but they're stranger in shape. They're the only one of its kind. So an example could be your vertebrae. Okay, so these oddly shaped pieces of bone that run up, making up your spine or your vertebral column, and they're different to the rest. Okay, they're special in their shape, and that means that they've got a special purpose. Now, in the case of the vertebrae, it's there to allow for cartilage in between each one, so it can slightly rock and allow some sort of movement, such as lateral flexion, or for bending in the spine, forwards and backwards. But there's also a hollow part in the middle. There's also a recess running down the centre of each vertebrae, with the sole purpose that the central nervous system can actually run through it. So it's almost enclosing these really sensitive nerves that run down and through each vertebrae. No other bone does that, just the vertebrae. So irregular bones, they serve a certain purpose. They're strange in shape when we compare them to the other three, and they serve a particular purpose. So the vertebrae could be a reason to protect nerves. Oh, I'll just put that into function. So in sport, you can apply it to anything. So for example, in the high jump, when the person needs to jump and possibly flop, the vertebrae are all sort of flexing and moving around each other. As that happens, the nerves running through that spinal column, they're safe, because the bones have enclosed them in a piece of bone tissue, so they're not going to get damaged, they're not going to get impacted on. So high jump could be an example here for the vertebrae, but the function is, well, it's got a special function. For example, it protects nerves, and that's our irregular bones. Then we have the flat bones, which are there to protect, for example, in rugby. The short bones, which are wider than they are long, they're there for stability and more precise movements, for example, balancing in the ankle joint or in the hand and wrist where we grip a racket. And then our long bones are there for gross movements. So the muscles pull on these long bones like a lever, and we can create these large sweeping arcs with these bones, with our limbs, to produce large movements. For example, the tennis serve, forehand, rugby kick, etc. So they're the 4 different types of bones. I hope that helped, and I hope to see you again soon.